Hey, g'day, it's Prezzo. Thanks for joining me in the workshop today. Now this is episode 10 of building this Titan model aircraft engine. Now if you're new here and you haven't seen any of the previous episodes, there's a playlist up above there now and you can go back and check out the full build from scratch. And also if you are new here today, there's a little bit of a backstory about building this engine. Now a gentleman in the United States contacted me some time ago. His name was Roger Taylor. He's an ex-shop teacher like me, and he asked me if I was interested in building this engine. Now, I'd never built an internal combustion engine before, but I was keen to give it a go. And he sent me the drawings, so I had a quick scan through those and figured that I could probably make most of the parts successfully. Now, at the time I agreed to build the engine, he said I could keep it. It was entirely free. He sent it to me at his cost. I thought about it and I figured that the gentleman who designed this engine, George Ginevro, is now in his late 90s, and I figured it would be a nice tribute to George to finish the engine. If I can get it to run, I agreed to send it back to Roger, and he was going to negotiate it to have it put in the Joe Martin Museum of Craftsmanship, which is in California, and he was going to have it put in the museum under the name of George Ginevro, the designer. Now, I didn't know much about this museum, and up until recently I hadn't Googled it, I didn't know what it was about, but just recently I had a look, and this is a fairly serious curated museum with some excellent examples of model engineering and engineering in general. So if you are interested, you can Google the Joe Martin Museum of Craftsmanship and have a look at what they have there. But it would be an honour to have this engine put in that museum under the name of George Ginevro. Now today we're going to have a go at making two of the final parts for the engine. You can't see them because they're going to go inside, but they are the piston and the connecting rod. I want to show you what they look like, so let's have a close-up look. The parts we're going to do today are the connecting rod first, and then we'll have a go at doing the piston. May not get the piston finished, but we'll do some of the preliminary machining on that. Now these two parts here have been 3D printed at a scale of 2:1. And the reason I did this, I wanted to be able to see the relationship between the top of the connecting rod and the interior of the piston. Now when I looked at the drawings that were supplied in the construction notes, it wasn't immediately clear what the interior, the detail of this piston looks like. And here's a clip on screen now of the detail drawing for the piston, and I don't know, this is how I interpret it anyway. And you can see that there's a circular bore. There's sort of a slot which from what I can see is impossible to machine, and there's also an undercut directly underneath the crown of the piston. So when I modeled this up in my CAD software, I printed it out, and I can actually put this together, and it does work. So if I put the two halves of the piston together like that, you can see that circular bore in the center quite clearly, and the top of the connecting rod does fit into that, and it does what it's meant to do. But from my point of view, I thought it would have been better to have a continuous slot all the way across rather than have that circular bore in the center. Now the slot would have to be wider than what is shown there at the moment in order to clear the top of the connecting rod. But what I'll do is I'll go ahead and make this part in aluminium, and I'll make a mock-up and I'll see how it works, and then if it's fine I'll make it out of this material. Now this is what's supplied for the piston. This is a piece of continuously drawn cast iron bar stock, very heavy, and we'll need to have a lot of stock removed from that to lighten it up. And the connecting rod is made from this material here. This is an aluminium block. It's about 1.25 inches long, 5/8 inch wide, and about 3/8 inch thick. And I think this is an ideal candidate to machine on my little CNC milling machine. The actual connecting rod really only has a couple of critical features, and they are the diameters of the bores at either end, which can be reamed, and the distance between those centers, which is very easy to do on the CNC mill. So that's how I'll tackle it, and what we're going to do first is get this stock cleaned up on one side, and then we'll put this on a fixture, and we'll do all of the machining on the other side, and then we can flip it over and finish out the pocket on the other side of the connecting rod. Alrighty, let's go to the mill. So with this stock for the connecting rod, all I've done here is rub this on one side on a file to make it reasonably flat, and we're going to put that on some parallels in the vise on the little CNC. And first job is to find the center of the vice jaws, so therefore the center of the part, and then offset from one end a distance which will give us some material around which we can cut either the big end or little end. I think I'll do the little end here, and then we'll move up and do the big end. Now, unfortunately, I don't own any thin parallels, so we're going to spot drill using these parallels in here, and then I'm going to have to move them from one end to the other so I don't drill through into that, which would be embarrassing. Okay, I'm going to use the probe now to find the center of the vice jaws, and therefore the center of the stock for the connecting rod. Okay, that's centered in Y, and now we'll find the edge in the X direction. Okay, that's the edge in X, and what we can do now is move in a distance which is a little bit greater than the radius of the small end of the connecting rod. Alright, it's about 6 millimeters. That'll give us plenty of material around the end of the connecting rod, and we've still got enough length to do the other end. Alright, just move these parallels so I'm still supporting the material, but I won't drill into it when I go right through. So this is the clearance drill size before we ream, 1/4 of an inch. Okay, we're going to use the G-code now to move to the other end, and we'll spot drill there and do the same process again, drill and ream. And although you could do a manual data input and just move the spindle the required distance, I wrote the G-code anyway, it's no big deal. So let's move to the other end. Okay, I've just checked that and we're all good. This brass bush here is going to hold this part down to a fixture, which we're just about to do, and the diameter of the top of that bush there is the same as the big end of the connecting rod, and we have clearance all the way around, so it's good to go. This is what I'm going to use to make the fixture to hold the connecting rod blank down to while we do all the machining operations. So I'm just going to put this in the vise, and we'll do the same process again. We'll find the center of the jaws, and we'll offset from one end, and we'll drill exactly the same distance apart as we've already done on that connecting rod blank, and then we'll tap that and we can hold the part down. Okay, that will do for the center of the hold down bolt that will hold the small end of the connecting rod. So we're going to go ahead now, we'll drill exactly the same pattern of holes, and we'll tap them M5, and then we get the blank set up. Alright, so now we can go back to our starting point, tap the other hole. That's the advantage of doing this with CNC. You can just go backwards and forwards from hole to hole, position to position. You do that all day long, and you're not going to lose any points or any accuracy. And there's no backlash, nothing like that to worry about. So let's go back to our starting point. Well, there's the stock that I drilled and reamed, and those little brass bushes will allow me to hold this part down to the fixture we've just done. And As long as I don't move from my origin position, which is this screw here, we can go ahead and machine all of the profile of the connecting rod. We'll do that first. Then we can come back and relieve the center of the connecting rod, and there's just some radii to go around each one of those bosses at the end. So I'm going to make sure that's nice and tight, and we'll come back and we'll do the profiling. Okay, I've done up a tool path which will trace the outer profile of the connecting rod. It's a very conservative tool path. Just remember, this is a very light milling machine. So we're just going to do a roughing pass right around the outside and then do a finish pass in a climb milling direction. And then we'll pocket out the center of the connecting rod with a separate tool path. Now, I'm starting this very late in the afternoon. I probably shouldn't do this, but we'll give it a go. Alright, I could have definitely gone faster on that finish pass, and I probably could have done a much deeper depth of cut. The first one there was 2mm depth of cut, 100mm per minute, and then the finish pass was only taking off 0.4 of a millimeter, and I was taking that at 3mm depth of cut. But yeah, like I said, very conservative, but better safe than sorry. So what we'll do now is we'll take out the center of the connecting rod to make a sort of a waist in the middle here, and then it's got to have a third operation which will put a radius against the boss at either end. Okay, pretty happy with that, no disasters. What we need to do tomorrow is to get a 1/8 inch ball nose end mill and contour out the end of that center pocket, so it'll sort of take a radius up to the top of the boss. And then we go flip it over and machine out the other side. It's got to be a lot shallower on the other side, and once again a bit of a radius at the end, and that part's done. Well, it seems that the PC that I use to run my little CNC milling machine doesn't want to be a team player anymore, and I came out here this morning, switched it on, got absolutely nothing, and I've spent the last 2 hours delving into the guts of this thing. I've disconnected, reconnected everything, I've cleared the BIOS, checked the power supply, changed the power supply, and still getting nothing. So I'm going to do the connecting rod the old school way, and that means doing it on the lathe. So let's go and do it. Okay, this is the alternate setup. So I've got a spigot in the 3-jaw chuck, and I've machined the end of that spigot to be the inside diameter of the big end of the connecting rod. Got a socket head cap screw to hold the connecting rod onto that spigot. And I've got a tool bit here which I've ground up. This has got a 1/16 radius, and I've set the DRO to the bottom of this section of the connecting rod here. So I'm just going to machine into that junction there and put the nice smooth radius in there, and then I'll have to turn this to the other end. I'll just turn the spigot down to fit the small end, do the same there, and then flip it to do the back. So that's how you do it when you've got no PC to run your CNC mill. Okay, that's pretty good. I reckon I can blend the rest of that with a file and some emery cloth, so I'll swap over now and do the other end. That's both ends blended out now. I think I'll turn this over and do this small end the same way and get the depth of this part started anyway. And then I might have to mill the back of this out, I'm not sure yet. I can do that on the manual mill. The back of the connecting rod, we only had to take 62 thou out of the thickness, so I'm going to put this back on the same spigot that I used to machine the front boss, and then we'll put the radius in the corner there. But if I had any brains, I would have done the two big ends first, or the two sides from the big end, and then swapped out and machined the spigot smaller. So now I'm going to have to make another spigot. So you see, Mark, this is why we can't have nice things. Alright, so I set the DRO to the radius of the end of the connecting rod, and then I'll set the depth as well, and I'll just hit those numbers. There's the small end done, both sides. I'll do the other one off camera, and then we're going to have a go at radiusing the edge of the center of the connecting rod. What we have to do now is get like a full radius on this edge, the skinny edge of the center of the connecting rod. And the best way I can think of to hold this for filing, that's how I'm going to do it, just entirely by handwork. I've screwed that down to a piece of wood, and that piece of wood is thinner than the narrowest section of the connecting rod. So I can get the file all the way over 90 degrees from this top surface right over that edge there. So I can radius the two top edges, flip it over, and then do the other side. So what I'll do is get this blued up, and then I'll put some scribe lines on, which will be the tangent points for the round. So what I'm going to do here is to set my dividers to half the thickness of the center of the connecting rod. And if I scratch that from both edges, and the two marks coincide, I know I've got exactly half that thickness. So what I'll do now is scribe that center line. And that will be where we stop cutting the curve, right on that very tangent point at the top. If I turn the part sideways, and I'll scribe the same distance from the two edges. And again, that's where we're going to stop filing. So I'm just going to do this one as well. The reason why I keep turning the dividers over is I've ground one point to be slightly longer, or one shorter I guess, and the longer point is the one that runs down the vertical edge, and the other point is the one that does the scribing on the top of the material. So the way I'm going to tackle this is I'm going to use a jeweler's file, and I'm going to come down at roughly 45 degrees, and then we're going to cut 3 flats. Now the first one, 45 degrees, and it will be about half the total distance we need to file. Then I'm going to change the angle of the file to roughly 30 degrees to the top surface, and we'll cut a small flat, and then we'll do the same again at 60 degrees to the top surface. So what you end up with is like 3 flats, 3 facets, and then you can just easily blend that into one continuous radius. Alright, that's about as far as I want to go there now. I'll take that out and have a closer look. So there's the 45 degree facet, and now we're going to do one at roughly 30 degrees to the top. Okay, now we're not quite at the line yet. We'll reach that when we start blending that to make it a curve. I'll turn this on the side. Okay, so this one really now is 30 degrees to the top surface as well. And what we'll do now is just blend all of that. So I'm going to use the process of draw filing. Alright, I hope you can see that, but we're more or less at the scribe line on this top face here, and we've reached the center line here, and I've blended all of that to make it into a sort of a curve. This is really just cosmetic. It does help to lighten the connecting rod, but it's more about just sort of creating a cosmetic appearance on that edge there. So I'm going to go ahead now and do the other 3 edges, and then I'll catch up with you when they're done and we'll check it out. Alright, I've been at this now for about an hour, and that includes all of the filing using emery cloth. Good thing here is you can sort of run it over the edge like that. I've also used 400 grit wet and dry. It's not bad. There are some areas that I'm not happy with. These areas in here, right where the straight section of the connecting rod blends in with the big end and the little end, they're the hardest parts to do. And if you get it wrong, it's immediately obvious. Any sort of curved edge like that, if it's got a flat spot or a hard edge, it shows up quite clearly. What I'll probably do here is get some Cratex on a rotary tool, Cratex points, and I'll get in there and blend all of that. And then I think what I'm going to do is to sandblast the finished part. So I'll blank off the bores, sandblast the whole thing, and let's face it, it hides all the defects, doesn't it? No, it doesn't. It provides a texture on the surface so the oil will hang on to that part. Yeah, that's it. Anyway, I'm going to go on now and have a go at the piston. Got a cool new sticker today, and this comes from Derby in New York State. I hope that's right, could be Derby. But Derby in New York State, right on the banks of Lake Erie. And this comes from a gentleman named Mark Carroll. And Mark's got a YouTube channel, and he's also on Instagram. His details are on the screen there now. But Mark owns Bridgeport, and his name's Mark, so he must be a pretty good bloke. Mark contacted me some time ago and sent me the details of this very interesting little circular collet rack. And this is what I call a supplementary collet rack. This is where all the good collets live. And I also 3D printed some little accessories here for things like centre finders and so on. But yeah, that's great. I use that all the time. Now I know I'm going to cop some flack for that earlier scene in today's video, but you know what? I got my Kevlar boots on today, and just to show you how good they are, there you go. Safety is no accident. Now I did go on and make a piston. In fact, I made two, and I'll show you the other one in a moment. But I decided it was better to try this out on a piece of expendable material rather than commit to the cast iron, because I've only got one piece of that. And it's a good thing too, because I screwed up pretty badly on this one. So this is a piece of aluminium alloy. It's a very free cutting material. I don't know what the exact grade is, but I suspect it's got a lot of zinc in it. It's quite heavy compared to normal aluminium alloy. And with this one I was able to get the outside diameter pretty close, a little bit oversized with this one, but that's how I'm going to machine the cast iron piston, and then it will be lapped back to fit. This relief section at the top here is where the baffle will be cut at a later stage. Now I was able to get the cross-hole drill for the gudgeon pin, and if you look underneath there you'll see that I've made a slot all the way across the underside of the piston. Now I decided to abandon the idea of putting the circular bore in the centre of the piston here, which is what's shown on the drawings, and my reasoning for that was that it would make a better fit on the connecting rod. Now the downside of that is it's very hard to get a boring bar through that narrow slot so you can undercut the crown of the piston. Now in order to make that work I had to machine up a special boring bar. So here it is here. Now I machined this out of some silver steel. It's a water hardening silver steel, and I was able to turn all of this on the lathe and then grind the end of that boring bar, and that will just fit through that slot. So it's going to be hard to show you here, but if I was to turn that slot sideways like that, the boring bar will just fit through, and then you can machine outwards and undercut the crown of the piston that way. I tried it on this one and it worked, but at that point I abandoned this one because I'd made some pretty bad errors. I think I bored the underside of the piston too far, and it's almost breaking through the cross hole. Okay, here's the second version. Now this one is pretty much complete. In fact, it is complete. I did all of the machining operations on that, including the baffle on the top of the piston, and that was done with a 4mm ball nose end mill to give us the correct radius on the bottom of the baffle, and then the rest was machined away with a 6mm end mill. Now this time I got it right when I machined the underside of the piston, and I was able to take the top of the crown out fairly easily. Now if you look carefully at this one you'll notice it's got a little half round in the bottom of the piston skirt. When I put the engine together I noticed that the piston was fouling on the crankshaft. Now I don't know why, it doesn't mention that in the construction notes, but it doesn't affect the performance of the engine at all. So I just took out a little tiny scallop there with the file, only had to do it on one side, and that allows the piston to move up and down in the cylinder over its full range. So with this one here I've already fitted this to the liner of the engine, and you can see the scrape marks on the outside there where I've driven that up and down just to be sure that it's taking the full stroke inside the cylinder liner. Now it's a really close fit. In fact, if you get it sideways when you put the piston in there it just won't go in. But you can see there that it's already quite firm in there, and later on we're going to have to lap the cast iron piston so we get that really snug fit. This has got no oil on it at the moment. It's slightly tight in the center there, but I didn't worry about it too much because I knew that this wasn't the actual piston we'd be using in the finished engine. Now I did lap the inside of the liner again because there were some burrs on the inside there from where I cut the ports. So I've done that with a slightly finer abrasive this time, and it's come up even shinier than what it was before. Right, there's the connecting rod fitted to the piston. The gudgeon pin is not finished yet. It needs to have a hole drilled right through the centre and reamed, and then some little aluminium caps go on the ends of the gudgeon pin to make sure that it can't slide sideways and scuff the inside of the cylinder liner. But we'll do that later. For the moment, I can now move the connecting rod over its full range, and everything's a nice firm fit, which is good. But I guess what you really want to know now is, can we put the engine together and can we make it turn over? Well, let's have a look. Now, I knew I wouldn't be able to end today's episode without showing you this. Now, just bear in mind, I've only got half the bolts in the cylinder head and only half in the back plate. I don't have any gaskets in the engine yet, and nothing's torqued down really tight. Now, we also don't have the hole through the centre of the venturi yet, and when that's done, there will be a connecting hole from the venturi through the crankshaft and into the hollow bore of the crankshaft, and that will draw air in to the crankcase where it will get compressed, and that will pop up into the cylinder chamber when the port's uncovered, and that'll complete that two-stroke cycle. But this is what it sounds like at this stage. Now that is encouraging. Now that's exactly as I remember hearing it when I was a kid. That sort of feels the same, so I'm very encouraged to keep going forward. Now I must also say I do appreciate the comments that have been coming in on this build. There are ever so many people who say they can't wait to see it running or hear it running, and yeah, well, me too. But yeah, that's totally encouraging. Now in the next episode we're going to do the real piston. That's made from cast iron. It's going to be lapped to a much better fit than what I've got with this aluminium piston, and that's going to improve the compression even more. And I'm sorry I didn't get to it today. It's a lot more complicated than I imagined it would be. So I thought it best to actually devote a whole episode just to making the piston. So that's it for me today. Thanks for watching, and I'll see you on the next episode. And yeah, it's Prezzo signing out. Oh, that sounds so cool.